everyone, welcome back. Welcome to our channel, Sir Ranaran's Math Tutorial with our lesson to be discussed today. Okay, but before we discuss, smile muna dyan. I'd like to say thank you muna to the following who subscribe our channel. The YouTuber also, it's Grace Place. Thank you for subscribing, and to J Lord Minyusa, thank you so much, yeah Lord. And to Engineer Georgilyn Barlisan, thank you so much for subscribing, ma'am. So here we go. Be with me because we are going to discuss now our lesson of today. Let's concentrate this time on the measures of variability, and is for group data. We can recall that the measures under this are the range, the variance, and the standard deviation. So we're going to calculate. Our objective is we can calculate the following measures using group data. Okay, and that of course we need the help of the formulas. For the range, for example, we have here R is equal to UBHC minus LBLC. That means the upper boundary of the highest class minus the lower boundary of the lowest class. That's for the range. What about the variance? The variance is equal to S squared is equal to the sum of F times the square of the difference of the class mark and the mean, all over the sum of F minus 1. Okay, the sum of F minus 1. So we have the standard deviation. The standard deviation is equal to S is equal to the square root of the sum of F times the quantity, the square of, okay, the square of the difference of the class mark and the mean, and then all over the sum of F minus 1. Or shall we say, it's just the square root of your variance. Okay, we need also the formula for the mean, since we need to get first the mean so we can complete our data in the table, and so gradually we can complete for the variance and standard deviation. Our mean is equal to the sum of fx divided by the sum of f. This symbol is called mu, and that's to represent the mean for a greater population of samples, okay, of observations, okay. And so let me use this table to have calculations on that measures. Okay, here this table provide already the class intervals, okay, and that the lowest class is written in the bottom. Sometimes it's written in the top, so you're going down or you're going up. Well, anyway, it's the same. Okay, here and the lowest class is in the bottom, so it's most of the time it's like this, no, from the bottom going up. Now, encircled here is 45. 45 is the upper limit of the highest class, and encircled here is 11. 11 is the lower limit of the lowest class. Why are we emphasizing these two numbers? These two numbers are actually going to help us find the lower boundary of the lowest class and the upper boundary of the highest class to compute for the range, of course. And so the next column is the frequency provided also. Here we have the data, we have the numbers 4, 6, 10, 12, 10, 5, 3. Get the sum of that frequency, that's equal to 50. That means there are 50 observations in this data, okay, or 50 scores in this data. Next column, which is X, that's known to be the class mark, okay, the class mark. Others call it midpoint, okay. Work to get and how to get the class mark. Actually, you're just going to refer to your class intervals, your classes here, okay. You're just going to, add the lower limit and your upper limit in that class interval, then divide it by 2. Again, lower limit plus upper limit divided by 2, so you can get your answer. That's the class mark already. Example, 41 plus 45 equals divided by 2, that will be 43. Okay, the sum divided by 2 equals 43. So you will do the same with the other class intervals, so you can get the class marks. Okay, now the next column is the fx. That means you have to multiply your frequency and the class mark. Okay, frequency times class mark. So you have here 4 times 43 is 172, 6 times 38, 228, 10 times 33 is 330, 12 times 28 is 336, 10 times 23 is 230, 5 times 18 is 90, 3 times 13 is 39, and then you are going to sum it up. Okay, so you have here the sum of fx that's equal to 1425. You can use your calculator to make it faster, so if you're doing the Excel, then better. Okay, you have here 1425. Why are we trying to get the sum of the frequency and the sum of the fx? Because this will help us do our next column wherein the mean is needed. Okay, the mean is needed. So it says here the difference of the class mark and the mean. Okay, how to get your mean? Here it's 28.5. Where we got that? Okay, here. Take note, the formula for the mean, look at this formula here in the bottom side no, sa left. Okay, have the mean is equal to the sum of fx divided by the sum of f. That's why we sum up all the fx and the f, because we are to use that for the mean. Okay, so 1425 for the sum of fx, and the sum of x is 50. You divide it by by 50. Okay, that you have now 28.5. That's why we have here in this column 28.5 as your mu, or the mean. Okay, 43 minus 28.5 is equal to 14.5. 38 minus 28.5 is 9.5, and 33 minus 28.5 is 4.5. 28 minus 28.5 is 0.5, and 23 minus 28.5 is negative 5.5. 18 minus 28.5 is negative 10.5. 13 minus 28.5 is negative 15.5. You can do this, you can, if you want, you can use your calculators. Okay, now after that column, after you got the difference, you're now going to square the results or the difference. So that's why here in the next column you have the quantity of x minus mu squared. That means the class mark minus the mean results are to be squared. Okay, so here in the first you have 14.5. When you say square it, you just to multiply it itself, right? 14.5 times 14.5, or you may just say 14.5 squared. Yeah, what is 14.5 times 14.5? You have 210.25, and then you do the same with the rest. So 9.5 squared, 90.25. 4.5 squared, 20.25. 0.5 squared is 0.25. Negative 5.5 now is positive 30.25. Negative 10.5 is positive 110.25. Negative 15.5 squared is also positive 240.25. Okay, now what is this last column? The last column is actually the product of the frequency and the results here. Okay, the results here, it's the f times the quantity of x minus mu squared. That's why you just multiply these columns, these numbers here in this column, and its corresponding frequency here. Okay, so for example 210.25, you multiply it with 4, then you arrive at 841. Okay, 90.25 times 6, that's 541.5. 20.25 times 10 is 202.5. 0.25 times 12 is 3.0. 30.25 times 10 is 302.5. 110.25 is times 5 is 551.25, and 240.25 times 3 is equal to 720.75. Then you will get the sum. Okay, you add all these numbers here because it's needed in computing your variance. So the sum of this, you can use a calculator, is 3162.5. All this data here, okay, the data here is now our concern, so we can solve for the variance and standard deviation. Now let's try. Okay, solving for variance. Okay, solving for variance. Since our variance is s squared is equal to sum of f times the quantity of x minus mu squared, you have the value already in the table. As you can see here in the upper rightmost, the values are taken from the table. You have here the okay. You have the sum of frequencies 50. The sum of x minus mu squared is 3162.5, and the sum of fx is 1425. Okay, so solving for range first, you have here R is equal to UBHC minus LBLC. That means upper boundary of the highest class and lower boundary of the lowest class. As you can see here, the upper limit is 45. So add ka ng 0.5 to have the upper boundary. So you have 45.5. And you see the lower limit is 11 in the lowest class. So subtract 0.5 because we're talking about lower boundary. So the lower boundary is 10.5 since 11 minus 0.5 is 10.5. Now you subtract 45.5 minus 10.5, then you get the range 35. That's it. Now solving for variance. Formula for variance is s squared is equal to the sum of f times the quantity x minus mu squared. And you have the value already here. It's the 3162.5. You're just going to substitute here. Okay, substitute. And then what is this? The sum of f minus 1. You know your sum of f is 50. So minus 1 is 49. Okay? So then divide 3162.5 divided by 49 is 64.54. That is your variance. Now solving for standard deviation. Since your formula is the square root of, the variance, that's a variance. You are only to take the square root of that variance, the same. So that's 64.54. So you take the square root of 64.54. Again, why we just did do that? Because the formula of standard deviation is actually just getting the square root of the variance. Okay. So 64.54, get the square root, that's approximately 8.03. That means our standard deviation is 8.03. Complete. The range is 35, the variance is 64.54, and the standard deviation is 8.03. I think that's it. Thank you so much, guys. If you learned something from this lesson, if you think this helped you, please like and share it, and subscribe to my channel for more videos. Click the bell if you wanna be notified whenever we have new videos posted. This is your Sir Ren again, your teacher. Thank you so much. Bye bye.